All right, so this video here, we are going to be looking at absolute value inequalities. Now, we're only in this video doing the less than style ones. So here's a quick scenario. Inside, most people like about 71 degrees Fahrenheit for the inside temperature in their homes, give or take 3 degrees, so more or less by 3. So what is the temperatures? What are the temperatures that most people feel comfortable with? Well, we can kind of break this down. We can look at the minimum or the coolest temperature that people like. So that's 71, give or take 3 degrees. So we're going to take off 3 degrees from that. So that's going to be about 68 degrees there. And then the warmest that people would like it would be 71, give or take. So we're going to add in 3 degrees for the top end. So that's going to be about 74 degrees there. Now we can also use this information to write an absolute value inequality. Now these ones are a little bit kind of a mind bend in order to figure out how we actually do this as an absolute value. But here we go. So the T here is the temperature that one person prefers. And so the difference between the temperature that the person prefers and 71 degrees is got to be less than 3 degrees off. Okay, so here we go. The difference between the preferred temperature and 71 is going to be 3 degrees or less. So that's a way that we can kind of bend this into an absolute value inequality. So again, it's the preferred temperature from 71 is going to be less than 3 degrees. So just quick looking at here, we have an absolute value inequality here. We're just going to be testing numbers so we can just get an idea of what our answers are going to look like. So if we have this absolute value of x minus 5 is less than or equal to 3, what values from this number line are going to make this true? Well, let's start at 0. So we go 0 minus 5 makes negative 5. The absolute value of that makes positive 5, which is not less than or equal to 3. So 0, not a solution. Let's try 1. 1 minus 5 is negative 4. Absolute value is positive 4. Positive 4 is not less than 3, so no on 1. How about 2? 2 minus 5 makes negative 3. Absolute value makes positive 3, which is less than or equal to, in this case, or equal to 3. So 2 is a solution. 3 minus 5 makes negative 2, makes positive 2 for the absolute value, which is less than 3. 4 minus 5 is negative 1, turns to positive 1, which is less than 3. 5 minus 5 is 0, less than 3. How about 6? 6 minus 5 is positive 1, is less than 3. 7. 7 minus 5 is 2, is less than 3. How about 8? 8 minus 5 equals exactly 3, so it does equal exactly 3, or for the or equal to there. 9 minus 5 makes 4, not less than 3. And then 10 minus 5 is 5, not less than 3. So for these absolute value inequalities, we kind of have a range of numbers kind of here in the middle of our number line that make it true. And then outside of those numbers, out here to the right and over here to the left, not going to be solutions. So let's look at this example here talking about rainfall in Seattle. So normally it's about 40 inches per year, give or take 10 inches. So it can differ by 10 inches from the average for the year. So what is the range for annual rainfall for Seattle? So writing the inequality isn't super duper straightforward, but here we go. This is it here. So our average rainfall for this year, or whatever year you're talking about, from the average, so the difference between this year's and the average is going to be less than 10. So that's how we do less than or equal to 10. So that's how we do this. Rainfall can differ by 10 inches. So it can be up to 10 inches more or up to 10 inches less, is basically what this is saying. And then for an absolute value equation, this is the way we write it out. So now we can solve this. Now, there is more than one way of solving these. I'll show one way on this page, and then on the next page, I'll show another way. So for this way here, remember when we had equations here, we would break it up into two cases. We'd have equals the positive case and equals the negative case when they were equations. Well, that's the same strategy we can use with these absolute value inequalities. So we can do our positive case here where we just write what's inside the absolute value and then less than or equal to 10. And then for the negative case, there's another twist with that. We're going to switch the direction of the inequality also. So remember with the rainfall idea, it was less than above 10 or greater than 10 under. So it was give or take 10. So it was between 10 over and 10 under the average rainfall, which was 40 in that case there. So with these ones here, we go ahead and solve each separately. So for case 1 over here, we still need to get x by itself. So we're going to go ahead and add 40 to both sides. So we just get x by itself, and then 10 plus 40 makes 50. And then for the case 2 over here, same step. We're going to add 40 to both sides. And so we have x is greater than or equal to, and then negative 10 plus 40 makes 30. So since we have both less than 50 and more than 30, we can also rewrite it like this compound inequality here. So your average rainfall in Seattle, the rainfall was X, so it's going to be between 30 on the low side, 50 on the high side. So remember, these always go less than and less than when we write these out. So 30 is less than the average rainfall, less than or equal to, 50 is the most, okay, or equal to on that one. All right, so we solved it one way by splitting it up into 2 different inequalities. There is another way of solving it, and we're just going to call it for this video method number 2. So we start with our regular, just take off the absolute value and make it less than or equal to 10. We got that one. So remember, on the last one, we had the x minus 40 was greater than the negative 10. So that's basically what we're going to do here. So if this is greater than 10 or negative 10, then negative 10 is less than the x minus 40. So we can write it as one of these compound inequalities where we just kind of sandwich this absolute value between the positive of the number there and then the negative of the number right there. And now that we have this one, we can solve it just like we did the other compound and inequalities. So in this case here, we need to go from x minus 40 just to x, and we're kind of thinking of this as broken up into 3 sides, although in English it doesn't make a whole lot of sense to have 3 sides, but either way, here we go. So we need to undo the minus 40, so we're going to add 40 to all 3 sides there. So the negative 10 plus 40 is going to make 30. No more 40s here, just an x, and then 10 plus 40 makes 50. So that's an alternative way of solving this type of inequality. So here we go. Go ahead and pause the video and give this one a try. Come on back, see how you did. So here we go. We are going to solve this up, and we're going to be doing it by just writing it in one line here. So we have the positive case here. So we know that this s minus 3 has got to be less than 12. And it's got to be more than negative 12. So we can write it like this. And again, when I say more than, I'm looking to from right to left, so backwards from the way that we read. So the way this is actually read is negative 12 is less than s minus 3 is less than positive 12. Okay, but either way, the s minus 3 needs to be sandwiched between the negative case and the positive case of this number here. So now we can just solve it like we've done in the past. We want to go from s minus 3 to just plain old s, so we're going to add 3 to all 3 sides. Add 3 to undo that one, add 3, and add 3. Here we go. Negative 12 plus 3 is going to make negative 9, and then 12 plus 3, positive 12 plus 3 is going to make the 15 there. And now for our number line, remember we like to have 0 and then any other important numbers, in this case negative 9 and 15. These are both strictly less than, so they are going to get open circles there and there. And then the s is between, so we're going to shade between the negative 9 and the 15. All right, so here we go. So with any of these, remember when we're solving these, we want to make sure and isolate the absolute value. So what we want it to look like is this, where we have absolute value and then the less than and then the number. Well, here we have absolute value and then a minus 7 and then a less than and then the number. So this minus 7 we don't want here anymore because it doesn't take the same form as this guy here. So how do we undo this minus 7? Well, that's with a plus 7 to both sides. So here we go. So we have absolute value of x plus 0 just makes absolute value of x, and then negative 5 plus 7 makes 2, so less than 2. From here on out, we can kind of look at it. We have the positive case, and there's the negative case, and our variable is sandwiched in between, and this is basically all done. Remember, the big idea with these is we want to isolate that absolute value. We want absolute value, then the less than, or less than or equal to, and then our number there. So that's why we had to undo this minus 7 there. You don't have to do this step on all of them, but you do have to make sure you at least get to this spot here where the absolute value is by itself on the side of the inequality. So go ahead and pause the video, try this one out on your own, then come on back, see how you did. So we do need to isolate this absolute value. We want absolute value and then less than or equal to and then a number. So this plus 2 is not where we want it. So we're going to subtract 2 from both sides of that inequality. So that just leaves us with negative 3x minus 4. No more 2's is less than or equal to 7 minus 2 makes 5. And now we can kind of split it up into the positive case and the negative case. So there's our positive case. Negative 3x minus 4 is less than or equal to 5. And then it's got to be greater than negative 5. So negative 5 is less than or equal to negative 3x minus 4 is less than or equal to 5. Now we just solve. So we want to get x by itself and then the values on either side here and here. So undo the minus 4 with a plus 4 to all three sides. Negative 5 plus 4 is going to make a negative 1 is less than, and then no more 4's here, just the negative 3x is less than or equal to 5 plus 4 makes 9. Next up, we need to undo this negative 3 being multiplied, so we're going to divide by a negative 3 to all three parts. Now remember on this, we are dividing by a negative, so we're going to be doing some switching here. But let's move on. So we got negative 1 over negative 3. Negative divided by negative is positive. 3 doesn't divide evenly into 1, so we'll leave it as a fraction. And then remember, we divided by a negative, so we're going to switch the direction of that inequality. Switch the direction of the inequality there also. And now we have a positive divided by a negative, so that's going to be a negative. 9 divided by 3, 3. So negative 3 there. So this is written backwards. It's written from biggest to smallest. We normally don't leave it that way, so we would rewrite it this way. So negative 3 less than or equal to x less than or equal to 1/3. Now for our number line, we like to have 0 and then any other important numbers. In this case, we need a negative 3 and a 1/3. These are both or equal to, so they're going to get shaded in dots, closed circles, and then x is between, so all of our solutions are in the middle where the greater than negative 3, all of these ones intersect with all of these ones here. So just remember, make sure and isolate that absolute value. If you have any pluses, minus, even if you're multiplying something by it, you need to unmultiply to get just the absolute value by itself, then the less than or equal to, then a number there. And then we split it up just like we did with the and compound inequalities. You can either do it this way or you can split it up to where you're just doing this part here and you're doing this part here. So a couple of different ways depending on which way you like working it the best.